This is TLC305, and I am Robin Harwani. I lead the solution architecture team for worldwide partners within the telecommunication industry business unit. And so this is, we're going to talk about Edge and our journey over the last 3 years within the telecom and industrial customers, and a latest announcement of Outposts as well, and how that fits into our overall Edge journey. For those of you who are here in 2017, we started our first kind of forte into the Edge compute conversation with AWS IoT Core Greengrass, which was basically the extension of AWS IoT to the Edge. And from there, we went into 2018, where we talked about private networks powered by CBRS, based on, and there we had edge computing with machine learning inference at the edge that we demonstrated. And a lot of our customers at that point gave us the feedback that we're really looking for the ubiquitous cloud experience at the edge, which means not just the AWS IoT platform, but for a lot of requirements, they were looking to have compute, storage, and rest of the services at the edge, and have an experience that was ubiquitous the same way that they used the region. And we announced last year AWS Outposts. And within the telecommunication customer base, I've had the privilege to work with a lot of our customers in the early days of as Outposts was announced, and we defined a lot of requirements and helped shape the product. In this session, what I'll be talking about is how Outposts can be a key enabler for Industry 4.0 use cases that require single-digit or at times less than 20 millisecond low latency for industrial implementations. And it can also serve as a ubiquitous extension for the entire application ecosystem to the edge of the network that you may have. So the agenda, we're going to go into Industry 4.0 and the role of edge computing in it, just baseline the problem statement and understand it, define our solution approach with AWS Outposts, and dive deeper into the architecture. And as we go through that, there is a lot of other things that are very, very important, not just the services that we have, but the entire ecosystem of partners and the community of partners that we have and that we leverage. So I'll talk about that as well, and then close it off with the lessons learned. So Industry 4.0 and the role of edge computing. If you think about it, industry, the most customers that we have talked to, whether it is the manufacturing customers, it's the mining customers, customers within the oil and gas space, or the ag tech customers, they have given us feedback that they really want to transform their processes, the industrial processes, and look at bringing intelligence into their industrial processes for faster and more efficient delivery of their product. In warehouses, where there is complex setups, for example, looking at factories where they're trying to do machine control, all of these, each of these customers, when we talk to them, they have given us feedback that they really are looking at a new way of doing things. And what they tell us is, it's not about mass production anymore. It's about mass customization. They want to customize the products and have new types of products that can be shipped very, very quickly. They no longer look at buying intensive machinery and intensive compute and storage and infrastructure within their factory environment, but they're really looking at leasing. They never want to pay upfront. They want to pay as they go. And they want to go away from manual processes into the automatic processes and have as much automation as possible. So as we look at and as we talk to our customers and we tried to find out what were the specific application use cases that were of most use for them, it was really predictive maintenance, predictive quality, asset condition monitoring, and a fourth variety that I'll talk about just in a little bit as well. So let's just talk about what are these applications that these customers look at before we dive into Outpost and all of the things that I'm going to share with you. So what customers tell us, if you look at an oil and gas customer, they're looking at anomaly detection They really want a ability to stream data, have the ability to predict where a machine part or a motor or things like that, which are being managed and monitored through the sensors they have in their environment, need maintenance, and they want to predict that instead of having to truck roll and have higher cost maintenance staff. And there, we have been using things like AWS IoT Core for a while, which enables our customers to do predictive maintenance. For example, looking at predictive quality, this is an example that we have shared before as well. Looking at soil sensor measures and looking at pH, the moisture, the nutrition and gases within the soil, AWS Analytics, IoT Analytics can provide you the prescriptive, predictive quality analysis for you to take actions back for improving your agtech agriculture produce. And the same thing goes to optimizing truckloads. When we look at the sensor measure, the truck between the weight and the idle time of the truck in the parking, there is a lot of requirement in terms of machine learning and analysis that AWS Analytics can offer to collect the data from the truck and build the model to predict the most efficient load for local location of the truck over a period of time. So those are the three that we have shared a lot over the last year or so. But the new set of use cases that we see is, I went to a few factories and I saw firsthand there are closed-loop machine control use cases. And these are use cases where customers are really looking to manage and control the things like cutting laser, cutting based on laser, and looking at a milling operation being fully automated. And for doing that, they are analyzing video at around 10,000 frames per second. So just to put it into context, that is 4,600 times more than an over-the-top service for video that you would see on your phone. And for something like that, you really don't have the capability in terms of networks. So far it has been a very hard problem to solve. And then there is also things like milling operations, laser weld, melt pools within warehouses, autonomous robotics, fixed wireless use cases for delivery of packages, making sure there is no collision there. So all of these, as we looked at them, these are a totally new set of use cases that need to be enabled for the customers. And there, the customers are giving us feedback that they're really looking for 4 characteristics: security, connectivity, and integrating into legacy equipment environments. And all of that is kind of underpinned by having reliable, low latency, high performance services from a network perspective as well as from an application perspective. And they want to do all of this while extending the same experience, the same tools that they have used for years in AWS at the edge of the network. So you may think that I could probably set up a Wi-Fi network that could give me a latency for 10,000 frames per second as well. But that's really not the reality. What we learned talking to customers is for scaling, the amount of coverage that is required, just if in this room, if you look at it, I probably counted there were like at least 8 Wi-Fi access points. When you want coverage in vast areas, you have a choice of setting up a dense Wi-Fi network, which is most easily to talk about is uncontrolled in terms of a lot of security variables and the policies that manage each of the device that has different level of performance requirements. In a room like this, we could probably set up 2 LTE small cells and probably cover all of you instead of the 8 that we have. But then, is that a scalable problem? Is this a real problem that is repeatable? So I tried to study the amount of venues and the places that really require this capability. So it turns out there is 3.3 million warehouses globally. and 10.7 million industrial and manufacturing plants that require capability for low latency over a period of time for them to really transform their industrial processes. And that really is the problem statement when we look at it. And the talk that I'm going to talk, the talk today that I'm going to give you in terms of how to use Outposts in this context. So when we look at it, it's great. I want to set up a mobile network. What do I really need to set this up for solving my industrial problems? The first thing you need is you need to know what are the kind of devices and the kind of problems you're looking at and what you want to achieve in terms of applications. Most customers do not start with thinking about what is the latency, the jitter, the performance, but they start thinking about what is my application and what are the characteristics of these applications. Once they understand that, they try to figure out the compute they need at the edge. They start thinking about what is the type of mobile network that I need in terms of the core mobile network, whether it is a 4G or a 5G network. Just by the show of hands, how many of you are familiar with LTE? Most of you, awesome. So LTE is basically what powers up your phones today. 5G is the technology that is coming up in terms of the mobile network evolution. And there's a lot that we can talk about there as well. But once they figure out, most customers figure out their problem, their application, the compute they need, the mobile core infrastructure required. They talk about provisioning of these services with the network. They try to automate as much as possible. They need to figure out how they can secure spectrum. The spectrum can either be from an operator partner, like the national operators that are there in US or in other countries, or it can be secured by the spectrum access systems like unlicensed spectrum like CBRS or multifier and so on. Then after they figure out all of these things, there is IoT gateways. They need to plan their network and have the radio frequency planning. And then they need to figure out their SIM infrastructure, whether it is going to be soft SIMs that is going to power up these devices, or it's going to be something like hard SIMs that they need to provision and make sure that they are securely transported to the location. Now, that is what they need to enable low latency mobile communication for their industrial application for one edge location. So if you multiply this problem for hundreds of factories, and I already shared there's millions of locations that need to have these industrial processes set up with the right level of automation, there is a lot of questions that the customers have. Who will do the planning of these private edge networks? How will the radios work together? What will be the devices? Will they device from one location, roam to the other location, and how will all of that get set up? What components do I need to set up at each of the edge location, and how can AWS make it seamless for me at each of these edge locations so I can set up my environment once and deploy anywhere that I need to and manage all these edge networks centrally. So that's kind of the feedback that we got from the customers. So to solve this problem, dedicated edge networks, we started in 2017 with Greengrass. We talked about a single site network last year. But this year, we're really talking about scaling the dedicated edge networks and what do we really need for that. So based on what we understood, the first thing we need is the ability to extend the 4G and 5G network functions to the edge, or network applications as they are called nowadays. The second thing you need planning, orchestration, and management for dedicated edge networks, and these will be multi-site edge networks. The third thing the customers talk about is extending the industrial ISVs, the independent software partners of ours, the same software that they set up in the cloud, they want to extend that over to the edge. That's the third key part that they talk about. And then fourth thing that I have learned over the last 3 years setting up these networks, working with our customers, is making it easy for customers to find the right devices for the right type of application and the right types of gateways that connect them. And not a lot of people know. I personally come from a background of applications and telecommunications. I'm not necessarily the expert to know every edge gateway that is out there and how best I can connect my devices to it. So to solve this problem, as Outpost was introduced, we started kind of looking at different reference architectures. And before I go into the reference architectures, I will introduce very quickly what Outpost is. There have been many sessions at re:Invent this year that describe Outpost, so this is going to be a quick summary. By the show of hands, how many of you have attended any of the sessions for Outpost? Okay, awesome. So Outpost and the role of Outpost within the dedicated mobile edge. To explain what Outpost really is, it's really an extension of an AWS availability zone within your data center. It is the seamless extension of our services that are managed fully by AWS, and you can simply secure an Outpost rack. You can have it implemented in your data center, power it up, connect it to your local network, and configure your local gateway that I'll talk about in a little bit, and have the same experience of using EC2, the same experience of EBS, and all the services that you need to extend the AWS capability to the local edge location. And what that enables you to do is your latency going to the cloud round trip is reduced dramatically. Once you build a software, an application in the cloud, in a region, you can seamlessly deploy it at the Outpost. You can extend the same VPC over to the edge as well. So let's get into what are the experiences that you get when you use an Outpost. It's the same infrastructure that we use within our public regions that we are taking to our customer premises, which means that it is fully optimized infrastructure, the same cloud-ready platform that we have been using for all of our regions is what we extend. We extend the same programming interfaces, the deployment tools that we have. So if you're used to leveraging a console, you still log into the console, you launch your instances within the VPC. You have the same CLIs, the same SDK that you use. In terms of deployment of your infrastructure, you use the same CloudFormation templates, Elasticsearch, Cloud9, your entire deployment pipeline is the same. The APIs that you use in terms of the services are the same. The monitoring infrastructure, the management infrastructure is the same. So if you have been using things like CloudWatch, CloudTrail for auditing your logs or monitoring your infrastructure, the same infrastructure is extended to the edge. And then you have things like Systems Manager, things like Cost Optimizer, things like Trusted Advisor that seamlessly extend to the edge of your network as well. So that's kind of pretty awesome. It's not just infrastructure, but it's the exact same platform, the full cloud that comes to the edge of the network. So what services does Outpost offer? If you think about it, it's within compute and storage, we have EC2 and EBS. Within, we have our VPC that is seamlessly extended to the with Outpost, and then we have the relational database services, the RDS, EKS as well as ECS. Most of you may know this, right? Yeah, ECS and EKS, both of them are available, the Kubernetes as well as our Elastic Containers platform. And then coming to EMR, managed Kafka, as well as FSX and SageMaker. So now, let's talk about what does really a developer experience look like when you have an Outpost environment set up. So if I have an availability zone where I have two VPCs, like you can see in this picture, and you have two subnets set up, on an Outpost you can have you can extend the same VPC. You can see there that if I can point to this. Okay, you can see this, that on Outpost 1 here, you have extended the first VPC, and you can extend the subnets on the same VPC or between the two outposts here. And on Outpost 2, you're just sharing that VPC between the availability zone in the region and at the edge. So that's the level of extension that we have thought through and we are looking at. Now, if you look at the connecting outpost to the local edge network, there is a construct of local gateways that allows you to set up between the outpost and the customer gateway. Most of you are familiar with customer gateways if you're used to setting up IPsec tunnels and direct connects. So from the customer gateway, you can have a local gateway, which allows you to have dynamic routing as well as static routing between your local network as well as the outpost. And then all of this is managed centrally from the region. So there's no infrastructure that is set at within the outpost that you are kind of is an overhead. It's all managed centrally from the availability zone that allows you to have all of the control plane running in the region. So now that we have kind of baselined the problem and we understand the building block of the solution in terms of outposts, let's get back to solving our 4 problems today. If you look at extending the 4G and 5G network functions to the edge, when I talked about the first use case where you have a single site mobile edge, dedicated mobile edge, which is a private network that you are setting up, you will have an outpost within a private venue. And in that venue, you basically will have an outpost that is an extension from your availability zone, where you have a lot of your management services like Systems Manager, Config. You can have CloudWatch, auto scaling. You can have CloudFormation, different templates there, CloudTrail. And in the same VPC, you can have within the region your spectrum access system from somebody like a Federated Wireless or somebody that can offer the CBRS platform for you to secure your spectrum, which is an important aspect of setting up your network. And then you can extend at the edge within the VPC. You can have your provisioning, your subscriber management, the core network, both the control plane, the 4G control plane and the 5G control plane, as well as the user plane, and then your different applications. And that will then integrate through the local gateway over to your radio network that you have, the access points that you can set up. Now, that was the most simplest, basic setup. But when you move further and you look at multi-site edge networks, you really need the same outpost capability. You can abstract out things like provisioning, subscriber management, the control plane of your mobile core into the availability zone, and then have the user plane running locally on an outpost for your network. And then have multiple applications like push-to-talk. You can have things like your machine control applications. You can have your IMS solution, or IMS is IP Multimedia Services, or you can have different firewalls and VCPs. The one thing that we learned as we were setting up multi-site edge networks was that having some sort of a SD-WAN solution that allows you to manage the back-end WAN is incredibly helpful, and that's where we have the control plane. You can see here for SD-WAN and the policy plane running in the region, and at the edge we can have the CPE or the virtualized gateway running locally along with the virtual firewall if you need access to the internet. So now, one step forward, multi-site edge, once you set that up, you still need to have the integration to all of the AWS IoT services from your devices. And to make that simple, what we have been working with is to think about the X509 certificate integration from AWS IoT, where we can bootstrap and provision these certificates on the devices, on the SIM cards as the devices are getting set up, and we have done that with some of our partners already. And we can talk about this with you after the session in terms of how this can be achieved. But what this really does is any device that comes now live on that network that we just set up, whether it is a single-site network or it is a multi-site network, it allows you to pre-authenticate and start streaming data over to AWS IoT. And that's incredibly helpful for the customers that are looking to speed up the process of onboarding thousands and thousands of devices. In terms of secure device onboarding, we also work with Intel in terms of SDO, their SDO platform, and that's a great option as well there. I'll share that in a little bit. So let's kind of go into, once you have your single-site or multi-site outpost set up, and you have the X509 certificate installation kind of bootstrapped, now you're looking at integrating the rest of your IoT infrastructure, the machines, the sensors, the network that you have. And for that, you need the local gateway that we talked about that would go into the existing infrastructure and then integrate through either a dynamic or a static route. So if you think about it, you have, at this point, set up your network. You have the application, the same application that you set up in the cloud in your VPC, extended to the edge. You have the core network. You have the SaaS integration for getting your spectrum. You have integrated to the AWS IoT platform for X509 certificates. And now you have your machine infrastructure integrated into the backhaul. So if you go, that's the bootstrapping that we were talking about, which you get based on the capability that we have within Outpost. But then we look at things like orchestration and management of these multi-site edge networks. It's a lot of work to do that. And as we talk to some of our enterprise customers who are a manufacturing company or a warehouse, they gave us a lot of feedback, but then our telecommunication customers gave us a lot of feedback where they looked at cloud-native tools for orchestration. They looked at various ISVs to provide orchestration capability, and also a lot of open source tools like ONAP and OSM and CBAM from Nokia and others to implement orchestration on top of the platform. And when I talk about orchestration, this is not about just one workload being orchestrated. This is orchestrating an entire service. For example, I want to provision video surveillance and push-to-talk on my edge network 1 versus I want to provision services like a smart conveyor belt or a robotics application on my edge network 2. And all of the components that we talked about, from edge core network to the edge components to the spectrum to the application devices, all of that needs to be fully bootstrapped. And there is a lot of things that come into that. So let's kind of dive into this as well. And one of the frameworks that is important here is etc. Those of you who are familiar with it, just raise your hand if you can. Awesome. So this is, for those of you who are not familiar with this, the key functions within orchestration of a network, there is onboarding of a network service, there is instantiation of network service, scaling of network service, updates to the network service, and then termination of a network service. And for each of these, a lot of our customers asked us, what are the native tools available and services available on AWS that I can just seamlessly extend to the edge as well? So I just went out and created a simple mapping here that you can look at. You can use AWS Service Catalog to have register services and have them in the catalog. You can instantiate new services using the service catalog and the CloudFormation. You can scale using EC2, autoscale, and Lambda. And I'll give you an example of that in a little bit in terms of network services getting updated. You can leverage config rules. You can tag your infrastructure. You can have governance policies that help you manage that infrastructure. And then systems manager, run patch commands, which we all use in the cloud can then be extended at the edge as well. So then, lastly, termination of network services. We are all used to doing that in the cloud. That's kind of extended as well. So that makes life very, very simple for those of you who are familiar with the legacy virtual network world, where all of it was on bare metal or detached. Even if it was running on 3 different hypervisors, it was a lot of hard work to get all of it working. Now let's go into the VNFM. For those of you who don't know what VNFM is, it's just an orchestration manager for your application, whether it is a network application or an actual application that is delivering service like a push-to-talk or video surveillance. So here, a VNF stands for Virtual Network Function. It can be your core network, your HSS in the 4G world. It can be your UPF or UDM in the 5G world. And you can leverage CloudFormation, EC2 APIs, console to instantiate these VNFs. And a lot of our partners do that today, scale the virtual network functions, even the OSS, the BSS infrastructure, and the same services on AWS are used for even the applications by our ISV partners for industrial applications as well. So I will not belabor this more. Going into the VIM, which is the Virtual Infrastructure Manager, which is nothing but the EC2 service itself is natively provides the capability to be your virtual infrastructure management. So all of that is available through the console or through command line or through the SDK to you in the region and at the edge, just like I talked about before. So what does that look like, right? Carrier-grade telco orchestration. This is one of my colleagues here who put this together for us. And he basically thought about all the pieces that I talked about. If you pull that into these services and map them into the HCMANO framework, you have these services that are available for you to not just deploy the OSS, the BSS infrastructure, which is the management and monitoring and billing of the platform from a operator perspective, but your network functions, your element management platforms, for those of you who are familiar with it, through native services that are available. And a lot of our partners are doing that today. And we have talked about this last year as well in a little bit of depth for SD-WAN and a couple of customers. So, but let's think about this. In an event-driven scaling of a network service, how would that really work like? If you have a set of EC2 instances that you want to scale out, you basically have CloudWatch events that you can use to trigger and understand the condition when you want to scale your infrastructure. You can use Lambda for notification, and from there, you can use DNS and Route 53 to scale your infrastructure. That's something that applies in the IT world just like it extends into the new network world with network applications. I just wanted to touch on this because it is incredibly useful for a lot of our customers to understand that orchestration can be done natively from all the way to your storefront, which exposes your services to your enterprise customers. If you are an enterprise customer like a factory, you can consume those services and then deploy them using the orchestration tools that you have available on AWS. And all of that is possible in the cloud so far, and with Outposts going GA at this reInvent, it extends the capability for you to do the same at the edge. So that is about multi-site, well, single-site or multi-site edge networks, integrating them to AWS IoT for secure device authentication. Then talking about integrating into your existing machine infrastructure, looking at planning and orchestrating your network. But then, as we have all of these applications, the customers, our operator partners came to us and gave us feedback that there is a need for an exposure layer for them to take these services and offer them to their enterprise customers. Some of these enterprise customers use these services through AWS Marketplace. They can go and set up multiple SaaS platforms and glue them together. But then if somebody really wants to buy a full solution, then we had to create something, an exposure layer, digital exposure layer. And we work closely with our partners, Accenture and Bearing Point and Mycom, Solona, and others to put together an exposure layer which integrates on one end to for all the way from a storefront that exposes the services like video surveillance, applications like push-to-talk, or services that for machine control for our customers and their customers, and then integrated into an order-to-cash platform, which is basically from Bearing Point in this case, that you can go and check out at the Telecom Lounge. In addition to that, for the multi-site edge networks, we tried to set this up here at re:Invent in the Telecom Lounge. You can take a look with multiple radio providers and set the whole setup helps us to kind of conceive a full multi-site edge network with the services that go over the top. And all the central functions from an SD-WAN perspective, from core network perspective are running in a region, from a control plane perspective, and the user plane running locally. So that was the second problem that we needed to talk about. The third piece that came up in early part of our discussion was extending the industrial ISP solutions to the edge. And AWS has had lots and lots of industrial partners. We have an industrial competency, so you can really take any of the applications that exist on AWS today and then extend them over if these are supported on EC2 infrastructure or on our container infrastructure over to the edge with Outpost. What we did as we were trying this out, it was a fun experience. This is our Amazon Robotics team that was here, the Amazon operations team, which worked with us to get the autonomous robot working at the re:Invent booth here in re:Invent. And the entire idea was to have a private LTE network to which this robot would attach. So that was kind of what we did. And you can really do that with any robotics platform if you have the platform support 3.5 gigahertz and attach it to an edge network, or you could have it attached to a public LTE network as well if you want to try that. But for low latency, you may want to have edge computing at within the factory, or a wavelength kind of configuration where the compute is within the edge of the operator network. So those are the two different ways you can realize applications that require low latency using Outposts or wavelength then. Now, more applications that we tried to set up just for fun, and we introduced a constraint for ourselves to use what exists and not start to use the ecosystem as the community of partners that exist rather than creating new things and leverage the platform and services that are available and the open source projects that we could. So we started working with things like building a conveyor belt, a smart conveyor belt that would be controlled with Amazon FreeRTOS. It would have AWS IoT Greengrass, machine learning inference at the edge to control to do the video detection. And then from there, have a management platform to analyze hundreds and hundreds of such conveyors in a real factory environment to using Amazon Sumerian. So that was a cool project that we tried out. We did video surveillance with Ionica Quick Start. You can go check it out. It's out there. Push-to-talk with Samsung, Motorola, as well as things like biometric authentication. So that was the problem number 3, extending the existing ecosystem, not having to do new development, and having the ability to take the platform and leverage the existing ISV partners and use them for real-life industry applications and do machine control, things that would matter for our customers. Now, the last piece that I talked about was an interesting one. A lot in edge computing space is evolving, and devices for some of the spectrums that are new and not have been around for a long time is hard to get. So we had to figure out what would be the best way for our customers to use the platform when they try to connect all these robots, these cameras, these high-intensity cameras that they may have, as well as things like what the machines that they want to attach to. We had to figure out a lot of these things, and the best tool, meaning that was useful for us, was the partner device catalog, the AWS IoT partner device catalog, where we could quickly go and figure out what kind of cameras that we could use for what kind of use cases, what could we use for in terms of platforms for IoT gateways, what were the choices that we had in terms of sensors, what were the choices that we could go around and look at different protocols that data supported, whether I wanted to offload to a Wi-Fi network, an LTE-M network, an LTE network, and in the future, CBRS as well. So that frames up all of our problems. What did we really get out of this 3-year journey, if I had to summarize? It's no longer really about a single venue, a factory, or a warehouse. Think hundreds of locations where you are setting up private edge networks. And for each edge network, unless you have the level of automation that you can get to all the way from a device to the compute at the edge, to your radio infrastructure, the core network, and your management and digital platform for somebody to come in and consume it, it's very hard for the customers, if you're a telecom operator offering these to the customers, or an end customer to start consuming this unless you have a plan around it. And AWS Outposts allows you to extend the industrial ecosystem to the edge. It enables to implement the network functions, the OSS, the BSS infrastructure included, both in the region and at the edge, and then have the cloud-native orchestration and management capability for your networks and applications seamlessly. And that is a huge enabler to drive the things forward, but that is also complemented by the existing edge services that we have, whether it is things like FreeRTOS to do machine control, things like AWS IoT Greengrass to extend the AWS IoT platform to the edge. We just launched containers at the edge on Greengrass as well. So all those things are incredibly helpful as well. When we look at our telecom customer partners, it is very valuable for them to look at this exposure layer that we have worked with our partners to start monetizing various spectrums that are being available, including their own spectrum, and our partners can use the same framework. And finally, the partner device catalog is incredibly important mechanism for somebody who is really trying to solve the problem end-to-end to bring the right device for the right use case. It's really, really an important piece. I can't emphasize that enough. So come check it out. You will enjoy it. We are on the 3rd floor of this building itself. I will stick around here for any questions that you may have. And then, or probably we can take it up at the lounge itself. And thank you so much for making it today. Really appreciate it.